This video is going to focus on combining like terms and reviewing the distributive property. So let's review the distributive property first. So the distributive property looks like this, where you have a number outside of a set of parentheses. That set of parentheses could have an addition sign or a subtraction sign in order to apply the distributive property. So the distributive property says we want to take the number outside of the parentheses and distribute it to everything inside. So notice you now have the A with the B and the A with the C. So let's look at some examples. So we have 7, and let's distribute it. So the 7 goes with the X, and the 7 goes with the 4Y. Notice I'm just putting the plus because there's a plus sign there. So then that would be 7X plus, and 7 times 4 is 28, and the Y goes with it. Okay, the second one, 3 goes to the -5, and 3 goes to the 9Z. So 3 times -5 plus 3 times 9Z. So this is -15 plus 27Z. All right, the next one, let's review here. So I just have a negative sign outside front of it. So the negative sign has to go to the 8, it has to go to the X, and it has to go to the W. When I look at this negative sign, there's a number there, I just don't write it, and that's a -1. So the negative sign out front is really saying you have a -1 times this whole set of parentheses. So when I do that multiplication and distribute it, you're distributing a -1 to each of them, and what that's going to do is just change the sign of everything inside of it. So -1 times 8, -1 times X, and then a -1 times W. So the 8 was positive. You can see now it's going to be a negative. The X was a positive X because of this out front of it, and it's now going to be a negative X. If I ignore the subtraction sign, a -1 times W is now going to change that to a negative W. And if I drop these signs down, I now look at something and it looks kind of complicated, so let's simplify it. So -8 plus a negative X. So this right here is the same thing as saying -8 minus X. And a negative right here make it a positive W. So again, notice right here, it was a positive 8, it's now a -8. It was a positive X, it's now a negative X. It was a minus W, it's now a positive W. Okay, and with that comes down to these two things here, which we need to understand what are the difference. So we have terms. So every expression is made up of terms. So if I look at these individually, change my color for you. So if I look at 7x plus 28y, 7x is a term, positive 28y is a term. So the terms are 7x and 28y. The terms for the second are -15 and a positive 27z. And for the last one, you have a -8, negative X, a positive W. Okay, so all these circled, and an expression can be made up of multiple terms. It's 2, 3, 4, 5, it doesn't matter. The coefficients are the numbers in front of the variables. So in other words, if I'm looking at 7x, and again I'll change my color for you. So if you're looking at 7x, there are 7 x's. So 7 is the coefficient of that 7x. The 28 is the coefficient of the 28y. The 27 is here. The -1 there, and then this would be a +1. Now I left these out because these don't have variables. So your -15 and your -8, the ones without variables, are considered constants. And those vocabulary is just important when we get to these next few slides, just so we understand vocabulary as we talk through them. Okay, so let's look at combining like terms. Okay, so in order to put these terms, these individual terms within a larger expression together, we have to make sure that they're like terms. So here's a list, a nice list of like versus unlike. So let's look at the like ones first. So in order for terms to be like, their variable has to look exactly the same. So that means the letter has to be the same, the power has to be the same. So 3x, 2x, because the x and the x are the same, they're like terms. For this one, we have x to the second y, x to the second y, makes them like terms. Here, these are constants. So anytime we just have numbers with no variables, they're obviously like terms because we can always put standalone numbers together with other standalone numbers. This one, take note of this one. So we have -4 AB and BA. Well, they look slightly different, but notice there's an A here and a B here, and there's still an A here and a B here. They're just flipped. So the order doesn't matter. It matters, do the variables the same? Do they have all the same letters with the exact same exponents? Looking at the unlike, you can start to see why they're different. So x and x are there, but notice this x has no exponent, that x does. Y and x, well, those aren't even the same letter. This one has an A, but that one has a B. This x is to the second power or third power. This x is to the second power. So even though the y's are the same, the x's are not, which make them not like terms. Okay, so the only way we can put terms together is if they're like. Okay, so go ahead and pause it and see if you can answer these few questions. So all you're doing is determining whether the terms are like or unlike. So pause it, take a few seconds, and just say yes they are or no they're not. So this first one would be a no or unlike. That's because the x is to the 2, the x is to the 3. B has 3 separate terms, but they're all the same variables with the same powers. So these would be like. This is similar to what we talked about. So again, order doesn't matter as long as same letters, same exponents. So those are like. And then these have the same exponents, but the letters aren't the same. So they're unlike. Okay, so now let's work on putting them together. So first thing we have to do when we're combining like terms is always ask yourself, are they like terms? If they're not like terms, I can't put them together. So, and think of them very literally. So if I'm looking at A, if I have 6 x squareds and I'm adding 7 x squareds, how many x squareds do you have? You've done this for a really long time in math, except you used to look at just objects. So your teacher would say, you have 6 apples and you add 7 apples. How many apples do you have? It's the same concept. We want to take these coefficients and do whatever the sign tells us. So 6 plus 7 is 13. And that x squared is the variable that's like, so that stays. B, I have 19 xy's minus 30 xy's. Those are like terms because those look the same. So take these constants, or take these coefficients, and do the math. So 19 minus 30 is 11. And then the xy are the like variable term, so that's what stays. Notice I haven't changed this x squared to an x to the 4th. I haven't changed this xy to anything different. Okay, C. So I have 13xy squareds minus 7x squareds y. These are not like terms. The letters are the same, exponents are flipped. So C, I cannot do anything more than what's already written. Okay, let's look at a few more that have more than just 2 terms with it. So I have 7y plus 2y plus 6 plus 10. So identify your like terms, which would be 7y and 2y. And then constants are always like. So go ahead and pause it, combine the red, combine the blue, and see what you get. So 7y's plus 2y's, this is 9y. And then your constants are a 6 and a 10, both positive, so that's positive 16. Now the question is, can you go any further? So many times we want to force this 9y and the 16 together and all of a sudden make it 25y. But 16 is a constant. It doesn't have a variable in it. So this is your final answer. Okay, moving on to the next one. So go ahead and let's do this first. So go look at that big long expression and just pause it and identify your like terms. So group your likes together and see what you have, and then hit play and see what I do. So we got negative 2x and positive x. Notice I'm taking the signs with it. And then we have actually 3 constants of like terms. So that's what you should have got with your grouping. So those 3 in blue, those 2 in red. Right, now go ahead and pause it now that you have the correct terms together and see what you get when you combine the red and combine the blue. So for the red, we have negative 2x plus x. Well, this is a 1, so it's negative 2 plus 1, which is still a negative 1, x. And then the blue, you have 0 plus 4 minus 11. So 0 plus 4 is 4. 4 minus 11 would give me a negative 7. So that's what you should have got when you combine them. Now I'm going to simplify this and say, well, I don't really need that 1 there, so this is the same thing, minus 7. Again, this is okay, that's correct, but this is how we would see it. Very good. All right, so let's look at these. So for these two here, We want to get our like terms together, but before I go and put all these constants together, I have to simplify what I know. So we reviewed the distributive property, and that's what we need to apply first. So if ever I see an expression that has parentheses, I need to make sure that I remove those parentheses first by using the distributive property. So we take the 4 and distribute it first. Notice I'm not distributing the 4 to the 20 because it's not in the parentheses, so only distribute what's inside the parentheses. So 4 times 4x is 16x. 4 times a negative 6, or a minus 6, but I'm going to review it as a negative 6, gives me a negative 24, or minus 24. Then this plus 20 can just be dropped down. So when I'm looking at this, I'm not done because notice I have like terms. So I have these constants right here that I can put together. So 16x, and then the minus 24 or negative 24 plus 20 would give you a negative 4. And that would be your final answer. Okay, so same thing for the second one. We need to distribute this minus sign. Notice I'm not distributing the 5. I'm distributing what's directly in front of the parentheses. And again, I'm only distributing what's inside the parentheses. So this 5 is going to hang out front. And when I distribute this negative sign, remember it's a negative 1. So that gives me a negative 3x. Negative 1 times a positive 9 is a negative 9. And the plus 6x drops down. Now I have these like terms, so the 2 terms with x's. And then I have my constants also. So that would give me negative 3 plus 6 is a positive 3x for the red. And then 5 minus 9 is a negative 4 for the blue, the constants. And that would be your final answer. Okay, go ahead and pause and see if you can work through these. They both have sets of parentheses, or the first one has 2 sets of parentheses. So make sure you're utilizing the distributive property before you combine like terms and simplify it all the way down. Okay, so let's distribute. So when I distribute here, I get negative 21x, because negative 3 times 7 is negative 21. And then I get negative 3 plus 1, or times 1, which is a negative 3 or minus 3. So that's what you should have got for the first distribution. For the second, I have this minus sign that I'm distributing. So that's a minus 1, which is going to make that a negative 4x. So notice how I'm just adding these as I go, just straight across. And then a negative 1 times a negative 2 gives you a positive 2. Notice my sign changed. Okay, so this minus 2 can also be viewed as a negative 2. Plus, positive, negative subtraction are interchangeable. So now, my like terms are here and here. And then here and here for the constants. So my variable like terms gives me a negative 25x. My constant like terms gives me a minus 1. Good. Okay, for the next one, distribute the 11 first. So if you did 8 plus 11 and got 19, and then distributed in 19, that's incorrect. Remember, order of operations tells me to do multiplication and division before I get to that addition and subtraction. So I have to do this multiplication of distribution before I worry about that 8 out front. So 11 times 2y is a positive 22y. And then 11 times a negative 9 is a negative 99. Alright, so my like terms here, the only like terms I have are my constants, my 8 minus 99. So my 22y doesn't have anything to go with, but the 8 minus 99 is a negative 91. And then that would be your final answer. So be careful on that. If you did 8 plus 11, that's incorrect because of order of operations. So make sure you correct that and note that so we don't make that mistake again.